session in the openBIM Awards 2025. In the next 90 minutes or so, we're going to hear from 6 different projects over 2 categories. The first category is operations, and I would like to go straight into the first presentation, inviting Gavin, who is not here to join us, unfortunately, but is joining virtually. Gavin, just check I can still hear you.
Yep, still here, Dan.
Perfect, over to you.
I'm excited to represent the state of Queensland, Australia, with the Department of Transport and Main Roads openBIM information delivery system. This presentation will address the judging criteria in the following format: key personnel, key openBIM information, key project information, followed by key outcomes. I represent TMR's digital systems team, which includes George Guerin, Brian McSweeney, Sonia Leah, and Carmel Donnarumma. This strategic initiative addresses industry-wide challenges such as interoperability, data accuracy, and lifecycle asset management. Through improved collaboration, cost savings, risk reduction, and enhanced lifecycle asset management, openBIM has transformed how TMR plans, designs, constructs, and maintains transport infrastructure. This innovative approach not only ensures better outcomes for stakeholders, but also reinforces TMR's role as a leader in leveraging digital technologies to build a more connected and sustainable future for Queensland. TMR does not mandate the use of proprietary software. By adopting open standards such as buildingSMART's IFC and implementing ISO 19650 workflows, TMR enables industry to use their preferred software while delivering consistent, high-quality data. The system's reliance on openBIM principles ensures long-term adaptability and scalability, aligning with global best practices. On contract award, our overarching BIM guidelines covers roles and responsibilities and directs the lead-appointed party to relevant BIM documentation downstream. Next is an Exchange Information Requirements, EIR document, accompanied by a BIM execution plan, BEP template. The BEP is the lead-appointed party's responsibility to develop in response to our EIR. TMR assesses the BEP at contract award, and we work collaboratively with the lead-appointed party as the BEP develops to meet the project's specific information requirements. The next layer down is a suite of information delivery manuals, IDMs, that structures the data within project information models from the supply chain. Through our team's active engagement with buildingSMART Australasia, we've ensured that our IDMs are in alignment with the content and philosophy of buildingSMART's ISO 29481, the ISO standard for information delivery manuals. TMR's IDMs contain definitions for a unique naming code for each object within the project information model, level of information requirements for each of our project review submission gates. We provide an IFC class and predefined type to assign to model objects, IFC property set definitions, and IFC attribute definitions. Collectively, these inputs structure the data of project information IFC models in alignment with requirements for automated validation and formatting for asset management system and GIS upload further downstream. Our IDM suite includes a BIM for bridges manual, a BIM for ITS and electrical manual, and a BIM for road furniture manual. These are included in our contractual BIM documentation. TMR has defined IFC set and attribute requirements throughout the life cycle of our assets, from design to manufacture and construction through to asset management. TMR object attributes documents are our IFC property set definitions for model objects. We defined an IFC property set for each stage of the project lifecycle across our engineering disciplines. Within each property set, you can see the attributes we've defined for each phase. TMR supports industry with customised software packages for applications that the department uses internally. We've customised both Revit and 12D with templates hosting BIM attributes. Where possible, we've applied automation to pre-fill attribute names as the user commences modelling. Our software customisations align directly with the requirements in our IFC object attribute documents and includes export functionality to custom TMR IFC property sets as per our documentation. The key outcome is an IFC carrying TMR custom attributes in property sets for review. Using a variety of collaboration software, the open source deliverables are reviewed against LOD and LOI requirements defined in our IDMs. The case study submitted for this award is a TMR road and bridge infrastructure project that is currently in construction in northern Queensland. A key outcome from the Townsville Connection Road project is the real-world application of how our information delivery system supports the data from multiple engineering disciplines. The interoperability of open source data has been leveraged through multiple software packages as the data has transitioned through each project phase from design to construction and into asset management. On receipt of Townsville Connection Road project information models at review submission dates, our team leveraged SimpleBIM to assist with automation of review procedures. Basic examples have been applied to SimpleBIM templates that were passed against the IFC model submissions. The SimpleBIM templates interrogated the IFC structure for IFC class assignment, property set names, and attribute values. Any non-conformances dashboarded by SimpleBIM were exported as a validation report and returned in correspondence to the lead appointed party through the common data environment. The learnings from SimpleBIM validation were applied as a key outcome to progress into development of buildingSMART's information delivery specification, IDS. The data structure of the IFCs developed on Townsville Connection Road project were test cases for IFC validation with IDS. Blender app with the Bonsai extension was leveraged to export HTML validation reports of the IFC passing against the IDS. TMR is subscribed to Finalists for automation of IDS development to align with our documentation. IFC class has been included as a restriction within each element's applicability. This enables us to validate attribute values against property set definitions published in our IDM. We're working towards publishing externally facing IDS in our IDM documents. This will add a layer of digital granularity to our project information requirements. It will increase quality assurance of the data we're receiving our project information rules from the supply chain. To format the Townsville Connection Road project information models for asset management system upload, SimpleBIM was used for IFC data extraction. TMR's asset management systems do not host or support any middleware or API. All of our databases are capable of comma-delineated CSV upload. The asset management team supplies a template. Our team uses export dialogues in SimpleBIM to map the IFC attributes to the required format. The fact that we have a BIM code for each element that our asset management system recognises is critical in this process. Defining IFC classes to containerise common object types is also key for mapping IFC data into the required format. From the verified project information models, the attributes of the bridge management property sets were uploaded to TMR's bridge information system, the ITS and electrical asset management property set to TMR's road operation asset register known as RAW. This wakes the asset management systems up to the new assets entering construction phase. The systems are then formatted to receive construction and asset management data further downstream. The project information IFC model on this project was produced specifically for the development of workflows and procedures for the use of IFC for bridge survey setout and construction. This IFC model is currently in use by construction surveyors setting out the structure. The model was loaded into field instrumentation. The geometry in real-world coordinates could be read from the field instrumentation display. A key deliverable in TMR's BIM projects is the as-constructed IFC model. The as-constructed deliverables on the Townsville Connection Road project were used as a pilot for integration with TMR's GIS framework, IMAPS. IMAPS publishes asset management data for TMR's civil infrastructure across the state of Queensland. All attributes and property sets assigned to the IMAPS for future reference. TMR's BIM object coding becomes critical again here, containing fields that our asset management system recognises, IMAPS sources, and publishes data from various linked Oracle asset management platforms and dashboards asset data for user. This advancement will see the ongoing collection of certified as constructed IFCs, georeferenced, and data published for query during operation and maintenance for our statewide network. openBIM has delivered significant benefits to TMR's asset management processes. Efficiency gains. Automating data validation and integration has eliminated the need for manual data entry, which has previously involved hundreds of lines of information retrieved from project drawings. This has resulted in substantial time and cost savings. Data accuracy. The structured approach to IFC property set definitions and validation ensures that accurate, high-quality data is uploaded into asset management systems. Lifecycle asset management. BIM data integration into asset management systems and GIS supports asset management activities throughout the life cycle of infrastructure, from design through to operation and maintenance. Interoperability. The adoption of openBIM standards such as IFC ensures compatibility across software platforms, enabling industry partners to work collaboratively while meeting TMR's information requirements. This initiative demonstrates how openBIM can bring value to infrastructure projects by fostering efficiency, collaboration, and long-term asset sustainability. By adopting openBIM tools and methodologies, TMR has demonstrated its commitment to delivering infrastructure efficiently and effectively for the people of Queensland. Thank you for the opportunity to present our content. Please stay connected.
Thanks, Gavin. If we could move on to the next presentation, please, which is the Water Supplies Department from the Government of Hong Kong.
I'm C.C. Leung from a Water Supplies Department, and I'm very honored to be here today with you for my openBIM presentations. So today's presentations will is organized into 5 main sections. I will go through it with you one by one. Okay, so here is the map of Hong Kong. Actually, it is the entire map. Our goal is to use the digital twin solution to digitize our physical asset. As you can see, the red and blue dots and color lines represent our water treatment plant, pumping stations, water mains, large water mains. These assets are interconnected, and then they are serving over 7 million people in Hong Kong. We use BIM to support the digital twin, enabling ongoing optimization and improvement, and that is the asset management as well as energy management. We are using the openBIM and BIM data to build a smarter, greener infrastructure with investment of 56 million and over 40 experts from IT, BIM, and hydroinformatics. We are creating a digital twin that helps us manage assets better and more effective. So better and stronger. Well, I always, when I see the Stephen Hawking, he always explained the universe is called a cosmic cookbook. This is our digital transformation cookbooks. We have 5 ingredients, which is the BIM, AI, GIS, and IoT. The system integration is vital to our success. Using the openBIM framework, we combine BIM, GIS, IoT, AI technology to deliver real-time insight, inform the decision, making intelligent operation across every water infrastructure asset. We have many BIM models, I'm sure, like the government agency or the commercial areas. So we have a lot of BIMs, but after the design construction, what are you going to do about it? How do you drive the value from the BIM models? Getting them to work smoothly, harmony together can be tricky sometimes. To solve this problem, we are using openBIM standard, BIM checkers, lightweight engines, AI, and large language model. Well, we tried the LLM, DeepSeek, ChatGPT, and Owens to help us for the optimizations. These two help us improve workflow, identify potential problem early, and monitor system condition more effectively. Before we jump into the details, let's sit back and enjoy a short video. That's our director. That's the desalination plant.
Our goal is to build a system that is both sustainable and resilient. This pilot project marks a major step in that journey, integrating openBIM and openGIS standards into STTSS and ACCA to enhance asset and energy management. Most recently, we've introduced large language models to further strengthen our smart water operations. This framework reflects years of advancement. Our water network produces vast datasets, from IoT sensor streams to detailed BIM models. We apply lightweighting techniques, using tools like Supermap to reduce system load while preserving essential detail. openBIM and openGIS form the backbone. Open structures asset data in ACCA. GeoJSON organizes spatial data in STTSS. Now, LLM enhances ecosystem by connecting, analyzing, and making the data more actionable across operation and maintenance. Operators can now issue simple commands such as identify maintenance priorities or optimize pump schedules. LLM respond intelligently, trained on historical records and simulation logic, leading to reduced energy use, operational cost, and risk. With openBIM and openGIS, we've built a connected, visualized system. LLM is our latest advancement. We collaborated with global water experts and share our AI-driven openBIM innovations, fostering the adoption of sustainable practices, bringing us closer to a sustainable, intelligent, and operator-centric future.
openBIM is a key to building a smart digital twin. Basically, openBIM or BIM is the backbone of the digital twin. It must be. It helps us to enable smooth data sharing and interoperability for our asset management information system. Basically, it's supported the asset management system, ISO 55000. And our smart trunk transfer support system, it also supports our policy, energy management policy. It's ISO 5001. So basically, it's asset management and energy management. We have 2 systems for supporting us. The ecosystems. Our software solution always support the openBIM standards because our assets are designed to operate over long lifespans. Actually, our water supplies department, we have 160 years of history, okay? So not surprising, we have water mains for over 50 years long. So several decades to over a century. To ensure safe and sustainable asset management, we require information to be continuously updated and stored in an open format. And it must be true, because like the infrastructure asset will stay here forever, more or less. And then we need a good digital data to support our operations and maintenance, of course. This approach guarantees data compatibility and provide a single source of truth throughout the entire asset lifecycle. This is the process map. We follow international standard I just spoke about, like openBIM, to manage assets across their full life cycle, from design, construction, to digital handover, operation, and maintenance. This integrated approach ensures smooth data flow, smarter decision-making, and lasting value. Our lightweight viewer keeps BIM model fast and responsive, even for large infrastructure projects. In essence, on the right-hand side represents the information, while on the left-hand side reflects the operation based on that information. So right people, right information at the right time. This is our goal. For the workflow, we integrate the openBIM into our workflow to standardize data and ensure interoperability and seamless data integration. It also enables smooth, efficient digital handover, essential for effective asset management and smart operations. This is quite important too, because we have a lot of BIM models, how it can be pulled together into a single platform. So we need to lose weight, okay? We need to lose weight. So I'm working hard on it. Handling a spilled BIM model can be challenging. We need to instruct the AI to filter the raw data and remove non-essential information. This ensures that only critical asset and operation are retained in the BIM model. Maintain an optimal level of detail and effective integration and streamline workflow. Well, what it means is basically you have a BIM model, you need to filter off the information that is not essential to you, and then basically we managed to put the efficiency up to saving for 55%. So you need a faster model in order to allow our user to work on it. We use openBIM to govern the entire asset life cycle. Okay, so the upper part is the development of the BIM model. On the right-hand side, actually, is a digital handover. Kobe and LLM, we need it because we are the infrastructure guy, okay? So the asset register is very, very important, it's critical. The IFC and the asset register are essential, basically. The lower phase focus on the operation and maintenance. When we have the Kobe and the data, and we will be able to formulate the maintenance strategy. So we want to do the maintenance optimizations, where Kobe data support maintenance strategy development and enhance asset management. Well, this actually I'm quite proud to show you. For actually the BIM model or the underground asset, I call it SAD and LAD. SAD is a surface asset database. What it means is the pumping station, treatment works, reservoirs, access road, all these are called a surface SAD. And the LAD is actually in Hong Kong, we have over 8,000 kilometers water mains, okay? So basically it's two different classes of asset, but we need a system, an integrated system to pull this asset together. We have BIM, we have digital mapping system, and we also have a work order system. So you need to keep track of the cost. So how do you do it? Of course, I'm going to show you. Okay, thanks. Okay, and also we did develop the smart trunk transfer support system. This is basically the process is more or less the same as the AMIS, except the challenge is the geospatial. So it's 2D, 3D, and at the same time, the digital mapping system all working together, actually for the energy optimizations. So AMIS used the openBIM to connect asset data, model, and inspection. It ensures consistency with IFC, support risk detection via LLM, the large language model, and enable smart mobile-driven maintenance for efficient asset management. So basically, we have a mobile device to capture the asset conditions. So the operator will go to the site, use the QR code to recognize the asset, and then to keep track of the asset condition. Basically, if we do the maintenance, we must understand what the asset condition is. It's simple, right? So if you know the conditions, you will be able to do the predictive maintenance, condition monitoring. You're able to save money on maintenance or electricity, energy costs as well. Simply said, we want our assets to be healthy. Simple as that, okay? For the STTSS, actually for our projects, like we spend about $300 million for electricity bill every year, okay? So we import the water from China. It costs us 3.4 billion a year. And for the energy cost alone is 300 million a year. So we like to optimize the energy, okay, for the pumping schedule optimization. This is basically the system that we develop. So our KPI, maintenance cost reduction. It's like a human. We keep ourselves in healthy. We are spending less on the medical, like going to the hospital, healthcare stuff, okay? Energy, okay? For the pump scheduling, we are able to do it smartly. So we can save energy. It's not that difficult. And then carbon reductions and data integrations. This all because of BIM. We need a good data and we need a good model. And then we need an open BIM framework. So it's open BIM framework, open BIM standard, and good asset data to do our business well. This year marks the 60th anniversary of Dongzhong Water, because like 70 to 80% of water are actually imported from mainland China, okay? So the senior official, Mr. Li Guoying, came over to Hong Kong, and then I was one of the guys that presenting this solution to the minister. So he recognized our innovative use of technology to ensure sustainable water supply. And we were quite lucky to receive few awards. And we also actually have won our award in Hong Kong this year. And then we were told that we also became the top 5 BIM award. Actually, the award ceremony will be in the November. But actually, it's not about the awards. It's about pushing ourselves. This is evidence that we are not too lazy. Starting from 2023 all the way to here, okay, you are the judges, okay? You actually, it's your colleagues who marks me, okay? So, keep me running like a rat. Okay. Sustainability, okay. Actually, sustainability for the infrastructure, I know everybody will understand it. Sustainability for the digital asset, I understand. And the expert here at the front are the top-notch experts. But sustainability for the next generation and younger generation, we must do something about it. Actually, I was asked to promote our solutions to using BIM model, because like the students are interested in the technology and we need to attract them to come into the field okay? So we set up the education exhibition booth, okay? Every year, I work with Hong Kong University to allow the master degree students to work with us. So they have a hands-on experience with our projects. At the same time, I can learn from them. They have the top-notch technology as well. I work with the dean of the Hong Kong University, and they are the top expert in the AI and the data analytics. So actually, I was invited by him again on the 19th to give us the senior government official about our digital transformation projects. So sustainability, infrastructure, sustainability, digital asset, sustainability of younger new generation. I guess these three things that would enable us to have a good quality life. Okay, so for the STTSS, the smart trunk transfer, our target is at least 9% of the savings, energy saving. So far we have achieved stage 1 and stage 2. So it is come together is 20 million. So when we upgrade our system with the variable fee stripe, it can save up to 30 million a year. Electricity a year and 18,000 metric of CO2. So actually, we have achieved the SDGs by 3%, so it's 10 million. Is real saving because like I checked it in the electricity bill and compared the electricity bill with the last year. So it is true. And then I'm accountable for my director and assistant director on that as well. Okay, key participants, right? So we work with BIM consultant here. He's my consultant, Felix. We work with Hong Kong Business School for the data analytics. So they help us for the data analysis part. And we work with the China Telecom. And underneath is the hydro informatics that you need the water expert, hydro informatics expert. And also we have Nanjing Institute of Surveying, Mapping and Geotechnical Investigation. This actually, they help me to do the lightweight engines. So you have BIM model, but you need to downsizing it or make it fit to work in the platform that we develop. Okay, so BIM and GIS and the asset management platform to monitoring energy for the energy savings. Okay, this is I'm CC Leung, the Chief M&E Engineer of Water Supplies Department. You can contact our project coordinator. We are happy to share what we have with the expert, all of you here. Thank you for listening.
The next presentation is Hing Construction Company.
Okay. Good morning. I come from the property developer and the owner of the recently completed building, the Henderson. I'm in charge for the technology and innovations from the early planning, design, construction, handover until the current operation stage. My partner here is come from the Hing Construction. It's the top tier BIM team in Hong Kong. The Henderson completed in the first quarter of last year. Tenant have already moved in, and the Henderson is now the new icon of Hong Kong, a successful showcase going to the media, industry, and the general public. Just like the Hendersons, we partnered with the World Green Building Council and filmed with BBC World and also National Geographic. And our anchor tenant, just like Christie, we are partnering to tell how is our ESG partnership aligning with our tenants' long-term operations. As the building owner, Henderson Land has been in Hong Kong for almost 50 years. Over the period, around 1 out of 10 residential units in Hong Kong come from us. Henderson Land is capable to manage projects throughout the building life cycle, from the planning, design, construction until the long-term operations. We have our own property and management subsidiary taking care of all the residential and commercial properties long-term operations. The operations of the Henderson is fully aligning with our corporate sustainability strategies. You can see they are green for planet, innovation for future, value for people, endeavor for the community. The Henderson is located at the heart of CBD. There's a number of architectural masterpieces around us. The Henderson, the usage is mainly for office, together with a banquet hall, F&B, and 5-story basement car park. The major spatial feature is its long span foreplay. You can see in the diagram, allowing higher flexibility in the usage. The Henderson has already received 10 different accreditations from the Green Building, Health and Well-being, Smart Building, and Sustainable Transportation and Lifestyle aspects. The purpose is to set out the future-proof framework to facilitate long-term sustainable operations. And a more important is the Henderson achieved the winner award for the buildingSMART International in the construction category in 2022. The achievement set out the foundation for the openBIM application throughout the projects and more capable to engage all the project stakeholders collectively to build up the cross-sector BIM and access database for the building handover and operations. To create a new icon of Hong Kong and for the general public, of course, we come across many challenges. At the same time, we also get opportunity. Just like the first example, we have a dream, is to build the city flower of Hong Kong into the building, the bud of Bohemia. Can we do it? Yes, it's possible by digitization. It come in place and make openBIM in place, we do it. And after the facade optimization process, we finally still have over 1,000 different curvature of facade panels. So it's definitely not feasible, not buildable by traditional construction method. So in our case, what we have done is go through the construction digitization. We don't have any spare parts. So in the case, we have to order any piece of new glass in the operation stage. We go through the same digitization process in the manufacturing. And the second challenge is climate change, extreme weather, public health and safety. Those are the prominent challenges nowadays. openBIM is useful in building up models, for example, computational environmental modeling, operational resilience, access database, and also BIM integrated facility management portal. And all the glass panel, we have the latest BIM model for factory fabrication. We have openBIM models for access management. We also have the combined BIM model going to our facility management portal. And we keep all those models in the CDE as the single source of truth. In the case of any glass replacement is required, what we, sorry, I forgot to press it. This one. In case we have to replace the glass, what we have done is just use the RFID scanner, scan the glass and get the access and then we order the glass. To tackle many other challenges in the building operation, the infrastructure was built based on 5 operation objectives. They are smart, green, health, resilient, and hospitality. The ultimate goal is to operate the people-centric, science-based office, embracing innovations for the sustainable future. We adopted digital transformation, enable an ESG token awarding scheme, and connecting with the openBIM spatial model. This diagram is illustrating the smart building integration ecosystem and how the integrated system powered by the openBIM. You can see openBIM enable the digital platform for better service and analytic opportunity for the building operator, property manager, facility management, customer service, and even going to our senior management at our headquarters building or the attending individual staff. We are talking about over 100 million dynamic data flow in the digital twin in a year. The openBIM application began from the CDE at the design stage and now carry forward to the operation stage. And openBIM also going to the assets and stock management, maintenance management, space management, and further connecting with the integrated tenant experience analytic platform, and also the smart tenant apps. And those operating data going to those platforms such as building energy consumption or ESG precipitations, they all go into the AI-enabled energy analytic and also our ESG analytic platform.
Okay, hello everyone, good morning. Still 5 minutes to noon, so good morning. Here we come to the main contractor's perspective. So it's about the technical part. Throughout the project lifecycle, we have used different software in terms of their expertise, like Rete, Tekla, CATIA, or digital projects. And then we factor the information through openBIM to support the wide diversity of expertise, enabling day-to-day smooth coordination, fabrication, and then operation. There's a saying, Rome hasn't built in 1 day. So that's a good model. An asset model cannot be built by one party, right? So starting from the delivery stage, our client developer already stipulated in the contract IDM that all the key stakeholders must engage in full BIM offering, open BIM exchange, and CDE use. We, as a lead of execution party, we standardize the IFC exchange protocol from different software by defining the right model view definition. And then it results in seamless collaboration from level of information need 300 to 400. We also use BCF as a neutralized medium for issue tracking in Solabri, in Trimble Connect, and so on. At handover stage, we form a facility management task force early 2 years before occupation, aiming to develop a proprietary Kobe cookbook for the Henderson, which we wanted to be rigorously standardized and friendly understandable by all the parties. Here, we want to express our thankful to buildingSMART BSDD and UCM, and also the Hong Kong government, who shared a lot of asset protocol through BSDD online, so that we do treasure their references there. Additionally, we use the IDS to validate our subcontractors' input in the as-built models, to ensuring that they have input the key parameters like asset code, asset group, and room parameters. At the handover stage, we form, we are going to the long lifespan. Now we are going to the long lifespan operation stage. The key information is asset code. It is vital because it acts like the human being identity card number to link all the asset-related attributes between BIM and operational digital twin platforms. And as we have deployed a meticulous open BIM process during the delivery stage, design stage, construction stage, we are now enjoying a bright road of data sustainability in operation stage. We want to lead the ISO 19650 to the 3rd chapter, not only about maintenance, but also about the future delivery, like renovations. So our end users, tenant, must take part. They need to update their asset model in IFC and IDS, and then submit the data to our facility managers through common data environment, so that over 1 million of data can fit and dance in the digital twin platforms. We are confident that this pioneer project sets the anchor of openBIM sustainability, especially in the private developer side. We are also dedicated to share our experience with the government, who wants to launch openBIM in statutory submissions by 2029. Because in the delivery stage, we set an anchor of openBIM foundation. Now, Edward will tell us more about how we can use the functions.
Okay, in the handover stage, we adopted laser scanning and augmented reality technologies to carry out quality check on site and also ensure what being handed over to our tenant and customer are consistent to the as-built drawings. When a tenant move in and prepare for the fitting out, what they have to do is they have to provide those BIM model, and then we have to integrate those BIM model into our building master BIM model, and also update our digital twin. The BIM is integrated in the facility management portal, as I mentioned before, in the handover stage, and the access information and the corresponding BIM model can be used on the web-based platform and also app-based platform, which will be useful for the maintenance on site and also connecting with the preventive maintenance module. The purpose of the digital twins is to realize data-driven building operational management and spatially enabled by the openBIM technologies. And the digital twin is now connecting with 45 smart systems inside the building via different communication protocols. Those are some user interface of our digital twin you can see in the actual building operation. The spatial model is originated from the BIM model, but visually enhanced to the game engine standard. The office interior environmental control, such as a solar blind, motorized openable window, room temperature, are all connecting with the digital twin and the smart tenant apps. Each of the devices are mapping with the static access data in the BIM and also the dynamic data points from the building system to ensure seamless control and monitoring in the indoor environment by our individual users. The Henderson is getting the tenant and the individual staff in the ESG journey. They collect and analyze the energy, water, waste audit, and carbon data from both landlord and tenant sides. And those are the part of our ESG partnership with our tenant and individual staff, embracing carbon neutrality, health and well-being, integrated culture, and partnership for good. As a successful openBIM and digital transformation showcase and now operation in place, we have put extra effort to share our experience and technology know-how to the industry, practitioners, and also students. Just like what happened last year, we offer our sharing in the buildingSMART Asia Summit, and then follow up with technical visit to the Henderson. And because we have been collecting a lot of data from our digital platforms, such as local weather station, the car park, or even for the electrical vehicle charging station, our digital twin is ready to share those data to the citywide open data, smart city open data platform, or exchange with other external data source. Finally, we wish to share with you some lesson learned.
The first lesson learned is information standardization and accountability. We've just mentioned our thankful to all the parties like BSCD, Kobe, and UCM given us the platform for inspiration. And then we are ready to contribute in return. And the second one is engagement. Getting the whole team into openBIM collaboration platform, we need to set up a dashboard and frequently monitor all the parties' engagement to encourage those who are reluctant to use the CDE. So the overall result is constructive, and we really encourage them to cultivate a good mindset. We value both top-down and bottom-up values, opinions.
In the capacity as a developer, owner, and also operator of the Henderson, the overall project management strategies obtain the blessing and also budget from our top management, and getting the right mastermind, right team, and set out the roadmap are all beneficials to the open BIM journey. There are many people getting involved in the operation stage, so the successful influence to the internal stakeholders will be crucial. So that is the end of our presentation. Thank you very much.
And also thank you for the organizers for handling the situations just now. Thank you, thank you.
Thank you. The next and final presentation in this category is ACCA software, Michelangelo.
Okay, so hello everyone. Today I would like to talk to you about usBIM.geotwin, openBIM GIS Digital Twin. So first of all, what is it? It is a system that allows to keep track of important assets at a territorial level without limits on the number of IC models used and their extension. The openBIM is always at the center because it allows to have democratization and demonetization of information, meaning that it is cheap and accessible to everyone. IFCs are always at the center, while IDSs, information delivery specifications, are used to make sure that data is actually in the models and for collaboration with other external systems, such as GIS, facility management, and so on. We will see more on that later. In particular, such kind of connection are bidirectional and dynamic and done via APIs, meaning that the exchange is in real time. So from the openBIM model, I can go through the GIS data, and vice versa, from the GIS world, I can query the openBIM models. What does it mean is that when we use tools such as, for example, spatial queries and analysis, we now get real-time results directly taking the data from the openBIM models. And at the foundation of all of this, there is the ability to edit the IFC models, because we think that this is fundamental, because in the operations phase, we can be many years after the handover, where we cannot rely anymore on the BIM authoring software that produced the openBIM model on the first hand. So there is the ability to edit such models in a dynamic way, both from a geometrical point of view, but also about the data. And BIM and GIS users are not disrupted in their jobs, meaning that they continue their independent operations. Other standards that are used are the BSDD for standardizing the information used, and the BCF, the BIM collaboration format, for communications among the users. But let's see some real-world examples. The objective that we have in mind is quite clear. We want an enhanced operation phase, and we want to make use of our digital twin to not make it just a mere digital shadow. So as a minimum, we would like to be able to use our openBIM models from different actors and from different people. And of course, we would like to be able to digitize the inspection and maintenance process. This alone will be worth the effort of creating the digital twin and to keeping it up to date. So let's start with an example. This is the Besta Museum from Italy, a small one, but very important nonetheless. So first of all, we can take a digital museum tour so people can experience it, for example, by consulting painting documentation. Just a technical note, as IFC is not very texture friendly, they have been overlaid on top of the IFC model. But we can consult the documentation. We can talk with an A-companion or smart guide to ask during our digital tour about specific of the paintings, but also in general about trivia about the museum, and also audio guides and other accessibility tools are very friendly for also impaired people to make the model accessible to everyone. Different users then, completely different users like painting and art restorers, are using the very same model to taking the effects of the painting for their maintenance processes, but always acting on the same IFC data underneath. And the possibility to enhance the model, for example, after survey with the cloud points, the possibility to create new objects, segmenting in an automatic or semi-automatic way, which allows to create new objects to attach documentation and so on. And in general, updating the FC model is very important for this museum because they host many temporary events and the furnishing needs to be rearranged. So again, we cannot rely on the original BIM authoring that created the model for that. And also, all the objects that are being added or moved around are directly connected with their asset management system in a bidirectional way. What does it mean? That we can inspect the asset management system of the museum, identifying the assets and see the tickets that are open, the status of the maintenance, and so on. Again, from completely different set of users. From there, we can decide to go to the model because we have this bidirectional connection with the objects. And from the model, we can select the objects and see the status of the tickets directly in the dynamic way with the asset management system. Again, same IFC model, different actors. So the IFC model on the CDE is the single source of truth for all the operations. Now, we also want to be able to gather data that comes from the asset in the real world and bring it to the digital twin. Then we would like to be able to do some analysis on such data, because we would like to be able to see what happens on the territorial scale, to see where we have to put intervention. So let's see this other example. This is from CUGRI, an Italian university consortium which is in charge of inspecting all the bridges of the public highway Avellino-Salerno, where they have to, for Italian regulation, made visual inspection every 3 to 6 months for each bridge and for each element of the bridge. So the system allows not only to attach drawings to each object, but of course also pictures and, most importantly, the results of the latest inspections. This allows the system to automatically calculate the damage level for the single object and for the bridge as a whole. But it is when we scale up at territorial level that we see the real potential. In fact, road owners, so again, a completely different category of users, can see on the territorial scale where the problem lies, where to put their money for intervention, and where there is a critical need to intervention, all while other users are keeping the system updated with the results of new inspections. And again, the IFC models are always at the center of all the operations. This is another example. This is from RFI, Rete Ferroviaria Italiana. It's public company for railway in Italy. First of all, for their digital twin, it's very important to be able to have the possibility to insert new IFC model and make them take part of all the operations that other models are already doing. So this model is in constant evolution. One example is the connection of some of their station photovoltaic system with IoT sensors. So we are gathering data in real time and geolocalizing and showing such information directly on the IFC model. Put this on a scale with the many stations, and we are gathering data from different photovoltaic sources and bringing this data for analysis. Last but not least, to make the digital twin really dynamic, there is a bidirectional connection with their facility management system in Rete 2000, which allows to update the IFC model, which in turn updates the facility management system, and vice versa. Users from the facility management system can change the values, and the IFC model gets updated accordingly to the RFI needs and specifications. Ideally, we would like also to be able to gather all of such data from the real world, to put on the digital twin and to run simulations on it, and to analyze such data with the business intelligence connection, because we would like to be able to make risk prevention, so to define what such risk criteria are, and to be able to analyze the data to act accordingly to prevent them or to mitigate them. This is another example, again from CUGRI, this time in collaboration with ANAS, which is Italian public company for roads and bridges. So first of all, we can see GIS data on geohazard risks combined with the model, and we have the possibility to make a walk along the alignment of the road, and to also have other kind of data, such as 360 degrees photos, navigable side by side. At each point, we can stop and see what is the associated geohazard risk level at that point of the road by querying the information on the GIS side. But as I was saying, it's important to have the possibility to gather data in a standardized way. And what this means is that road owners can decide how the different users of the system have to gather different kind of data. It can be data about road accidents, for example. It can be data about road defects that can be geolocalized in the model. It doesn't matter. They decide how the data is structured and why they put in this effort, because then they can collect data from all the users of the system and put them into analysis with the BI, business intelligence integration. So take, for example, the risk of car accidents. Once data is collected and structured in this way, we can use interactive dashboards and BI analysis to analyze the causes, consequences of such accidents, and also plan to minimize the same risks in the future. For example, we can expect similar roads which may behave the same. So by solving problem on one part of the territory, we can also have solution or mitigation for other parts as well. But with business intelligence, this is the power that we can analyze the data that we gathered in a standardized way from the different users of the system. Last but not least, a project fully dedicated to sustainability. It is called Rome Open to the Future and is a collaboration between ACCA Software, Esri Italy, and the municipality of Rome. Basically, it shows how to combine openBIM and GIS information to achieve some of the sustainability goals of the municipality of Rome. Such data in particular is about mobility, green areas, services, energy, life cycle impacts, and so on. And all of that is used to make strategic decisions. One example is the refurbishing of some old buildings to student rooms. And this has been chosen by strategically planning the distance to travel services and other strategic factors. And this is the example. There is also a refurbishing of an historic architectural building, which has been refurbished to be an hotel by keeping intact its architectural beauty and also by storing in IFC parameters the sustainability impact values, which, by the way, have been used in another project as BIM Sustainability, which is also a finalist for another awards. And in general, identification of best areas for new construction, keeping in mind the 50 minutes workable cities, and environmental analysis for achieving LEED green buildings, which is one of the goals of Rome, and of course, not only Rome. So in short, I hope that I shown you how Rome is using openBIM and GIS data connected together to achieve some of its sustainability goals. I am Michelangelo Cianciulli from ACCA Software, and we hope to have shown you some interesting real-world use cases from customers to enhance their operations. Thank you very much for your attention.
Thank you. If I could invite the first two projects that are here to come back up on stage, and we will try and get Gavin back. And we'll just have a short Q&A. We will keep it short in the interest of trying to make up some time that we've lost. So perhaps one question, one burning question for each project. Once they get here. Gavin, just check we can hear you.
Hello.
Yeah, okay, good. Who would like to go first from the jurors?
Yeah, I have a question for TMR. So, it's about the role of Excel. You used Excel in the workflow and pointed that out. Is that, do you think that's more a workaround or is it best practice? And do you see there's a gap that you bridge in standards or tools with that? So.
That's a part of our legacy asset management systems that we're targeting with data-rich models. We use a Excel-driven data transform from the IFC to the asset management system. So as our solutions mature, I can see that there may be more efficient ways of doing things. We've got certain disciplines that are using things like Python-driven data exchanges. But it's about being stuck with older asset management systems that we're using. Yep.
All right, thank you. Steen, for one of the other projects? Is it a quick one?
I'm not sure. Also a question for TMR. I think this is a very impressive, disciplined project setup and execution. Can you maybe expand a little on, give an example on how you use the openBIM as part of the operation?
Our most mature system is intelligent transport and electrical discipline, and we quickly had incoming operation and maintenance or work as executed data incoming to update our as constructed models. So because there's high frequency turnaround in maintenance of lighting on bridges and that sort of thing, we again use SimpleBIM to update the as constructed models with operation and maintenance data to update the already attributed models, and then it's a updated version of that IFC reflecting the O&M activities.
Thanks, Gavin. Different project this time, please. Hans?
Yeah, maybe a short question for each of you here in the audience. First of all, compliments, because it was really insights and really used practical projects. But can you elaborate a little bit more how these best practices and the experience are used now already in new projects or in the community?
Thank you. This is a very good question. I guess the word is best practices. Okay. So when we design our asset management information systems, we took the two approach. One is bespoke system, another is commercial off-the-shelf COTS. We actually have the hybrid of both. To answer your question is because like to have an AMIS system, the AMIS systems, we like for example, I won't mention the name. It's beginning with the Maxi Momo, okay, from the America, from the US. They have the best practices, okay. They have the templates, but we need to do the customizations for us because like we are the government agency, so we absorb some of the best practices from their system already built in, and then we actually go to the site and speak to the frontline staff, because like they are the one who knows the operation stuff well. So the key words, best practices, is operator-centric. Operator, okay, they will go there and inspect the things for you. They will go there and monitor the condition assessment for you. So it's very frontline. They need to understand their asset. Okay, they take care of your asset. So the best practices is, well, ISO. Plan C cycle. So Plan to Check apply in BIM standard, PDCA cycle apply in asset management ISO 55000, and PDCA apply in the 5001 energy management. Combine it to do it the total quality management, and then we implement it, and then keep all the data inside the AMIS system. As I said earlier, you need the good BIM data to formulate your maintenance strategy. After the information, you've analyzed the data, okay, and then you do it again, and then see where you can actually optimize your maintenance cycle, okay, and then of course attend a conference like this to talk with the experts like you know, sort of like to learn and share your works. I guess we have a lot of data. Frankly speaking, we have a lot of data, but I can share with you is the best practices. We were very fortunate because we have done the RCM, the Reliability Center Maintenance. The standard is SAE JA1011. Actually, is good enough for the aircraft. Okay, the aircraft industry, the maintenance standard they use is MSG, Maintenance Steering Group. Actually, the U.S. Navy also use these standards. Okay, what we have is the best practices. We have the FMEA, Failure Mode Effect Analysis. You have the failure mode. This is the treasure, and we use it, okay, for the inspection. And we deploy it for the potential failure curve. We know exactly, okay, the time interval to do the inspection before it actually fails. Okay, so this is very important. You need to understand your asset, how it behaves, what the failure symptoms, all that bound into the AMIS system. But as I said before, the backbone is the BIM. And the openBIM ensure the sustainability of the digital asset.
Let me try to answer these questions. We are now in the operation stage. You may be aware, I just introduced myself, come from the project team, from the early design stage. But now in the operation, why our contractor and me are still here? Because that is our flagship project. We have to make sure all those something new, there's many new things in our building can be carried forward to the operation stage. So that's why we are still here in the project. Let me answer this question in three perspectives. The first one is we are talking about openBIM. The first perspective is going into our internal stakeholders and our tenants. Just mentioned in our slide, we are talking about openBIM. It seems that we have used a lot in the construction and handover stage, but how to maintain the model, how to update the data in the CDE, how to encourage our tenants giving the new model and then we integrate into our digital twin is the key. The first method we adopted is we have green tenancy agreement with our tenant. So once they decided to rent our property, they have to assign the contractor to provide the openBIM model to us because we have the master model. And the second one, all the access data have to go to us because we have to maintain all the database. The third one, I just mentioned there are so many dynamic data, just like HVAC or energy data or other E&M data. Those are dynamic data, can come from the BMS system. They have to connect those data to us. So that is the first, of course, I just mentioned internal stakeholder. We have to provide training to our operator. The second one, the second perspective is the practitioners, because there are so many openBIM applications in Hong Kong. But how to carry forward from the design stage and then set up the roadmap to the operation stage, and in particular for the private sector, you may come across many public works, but we are talking about private sector. How to influence the private sector? So that's why we are so eager to share our experience to the industry practitioners. The third one is we are talking about openBIM to the general public. They don't understand what we are talking about. But when we are talking about digital twin integrated with openBIM application, they can see the model, they can see the visualization, they can see the energy analytic, ESG analytic, and then turn into the ESG reporting. Just like our anchor tenant, Christie, they have to publish their annual ESG report. Where are the data come from? Come from us, because we get the data from the landlord and tenant side. So that's why I said the openBIM application in the operation stage, we can say it from the three perspective. Thank you.
Thank you. I will say that from ACCA perspective, I think we have seen that there are different type of customers. There are the big ones, like the bigger ones, like RFI, public company, but also the smaller ones, like the Vesta Museum. So I think that for them, best practice may be very different. And so it's very important to have both of all perspectives on boards because they can lead to very different results. And so first of all, for us at ACCA, we always say that openBIM and IFC will be a success when even like dog houses will be in the RFI. So top to bottom, also these small projects are very important. And we think that also pushing from bottom up will help spread the openBIM community to a really global level. And in particular, in this case, for them, not only to start by using the system, collecting the data and so on, but also experimenting with it and willing to share their best practices is really to be something to be appreciated, because also often we don't see this sharing of best practices. So from our perspective, I think that having all of such different kind of customers on board is the best way to promote the spread of openBIM.
All right, thank you very much. That's all we have time for in the questions for this category. So thank you all for your answers, and you can please be seated. And we will quickly move on to the next category, design for infrastructure. I'm going to invite Terna up for their presentation.
Hello everyone, I'm Francesco Messano, Terna engineer, and now we talk about the initiative of openBIM design review. Italian Critical Station mission system. Rete Italia is supported by Capgemini Engineering Italy. It's represented by the architect Michela Cirelli near me. The goal of this initiative is to digitalize the design validation process from end to end, enabling designers and stakeholders to work within a standards-based platform from early planning to regulatory acceptance. This project aims to accelerate the validation process, improve design quality, and reduce design change during the construction of the of electrical station. Traditionally, validation relied on static reports and manual review. The project we show is located in south of Italy. It's designed to review and validate this electrical station. The solution makes use of digital twins openBIM standards and collaborate. To achieve our goals, we build an integrated design validation platform based on openBIM technologies.
Thank you very much. If I could invite the presenters from Terna back to the stage, and we'll just take a few minutes for some questions. Apologies again that we have overrun into the lunch, but fortunately we have an extended lunch these days, so you should have just under an hour for lunch still.
Thank you. Thank you. Both very interesting. I have a question for Terna. Can you just briefly explain, just in plain text, what are the key innovation compared with other openBIM validation tools and setups?
The innovations in the fact that we have a unique platform, a single platform in which all the actors can do not only the review of the design, but the validation of the design. The tools are not separated. We use a single platform to do something. The unique thing that we can do in the platform is the design, But in the platform, the designer, for example, the external design that we have, could take the library, the IDS, all the data model, and all our requirement.
I have one for the Japan ministry. The XML that you generate from the converter IFC to XML, is it an IFC XML or is it a specific XML? Does it follow any schema? Is it quantity XML or what is it?
Actually, in this March, we developed a system to convert IFC to XML, and XML is only for particularly designed for cost estimation, and but it is XML file, so not only for national cost calculation system, but also prefectural or other private cost calculation system can introduce this system to convert BIM model to cost calculation data. Yeah.
Any more questions? No? I'm happy to wrap it up, but if you have any more burning questions, we can... Yep. All right. Thank you very much. Then that does conclude this session. Again, thank you for staying, and we will now go and deliberate. Thank you.